Dr. Amit Kumar Yadav, Assistant Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana, India. So, my today topic is innovation in artificial neural network for solar radiation prediction. So, first of all, we will see some, say, basic term related to solar energy, then solar radiation. Then we will see why we require this ANN model for prediction of the solar radiation. After this, we will see some basic concept related to, or you can say that different types of model uh, which we are using for solar radiation prediction. After this, we will take one hands-on training with the help of say Python programming, how we can predict solar radiation. So um, let us see what do we mean by this solar energy. Now, uh, the utilization interest in solar energy came since 1970 due to rising of say fossil fuel. So in the world, solar radiation is abundantly available. So what we can see here, energy received per minute is greater than energy utilized by entire population in 1 year. So that's why due to this region, solar energy gain attention since a long time. You can say that uh, it is inexhaustible types of energy, and all energy, you can say that different types of renewable energy, it is caused by due to this solar energy, right? So how we can convert this solar energy into say electric power, being electrical engineers, so it can be converted through this photovoltaic systems. Therefore, in say rural part of India, we can install this photovoltaic system to convert this solar energy into power. Therefore, the information regarding this solar radiation is very much important for say photovoltaic systems. But for many developing countries like India, solar radiation measurement are not easily available due to higher cost of measuring instrument. So when we observe that most of the site in India, we are not having the solar measuring devices. Only few sites we are having. Due to this region, we have to use these artificial models to develop this model where we are having the solar radiation measuring devices, and then we have to use that model for the site where we are not having this measuring solar radiation instrument. Therefore, it is important to estimate solar radiation based on easily available meteorological data. So now we will see what are say different components of solar radiation. So try to see this figure here. Suppose here is a sun. So the solar radiation which directly strike the Earth's surface, this is called as direct solar radiation, and the solar radiation which strike the Earth's surface and it get reflected back, this is called as reflected solar radiation. and in atmosphere we are having cloud, and through that cloud the solar radiation component get absorbed. This is called as a diffuse solar radiation. So diffuse solar radiation, we naturally experience during say a rainy season. But when we consider the southern part of the India, there we are having that sufficient intensity of solar radiation. Therefore, we can use this photovoltaic system to convert this solar radiation into photovoltaic powers. Now, what are say important terms some related to say this solar radiation? First one say air mass. It is the ratio of say atmosphere mass through which beam radiation passes to the mass it would pass through if sun were it at zenith. Zenith means here directly overhead. So with the help of this equation, that is m is equal to 1 by cos theta z, where m is equal to 2 for zenith angle of 60. When you put here say 60 degree, it will come out say 2. So when the sun, so with the help of this equation we can compute the air mass. Beam radiation we have seen, it is also called as a direct solar radiation. It means that solar radiation received from sun without having been scattered by atmosphere. Diffuse radiation, it is a scattered from the atmosphere. So here radiation received from sun after its direction has been changed by scattering from the atmosphere. Total solar radiation is the sum of beam and say diffuse solar radiation, and on this total solar radiation it is called as a global solar radiation, and on this global solar radiation component our photovoltaic system work. Now here you will find out one term, irradiance, the rate at which radiant energy is incident on surface per unit area of surface. Then here irradiation or radiant exposure. So what it means, incident energy per unit area on a surface is found by integration of irradiance over a specified time. So here time parameter you can take usually hour or a day. So insolation is a term applying specifically to solar energy irradiation. So what are say different types of measuring instrument which we are using for say solar radiation? Try to see this one, pinometer, this part. This is used to measure say global solar radiation, this part, this instrument. Then we are having this pyroheliometer. It is used to measure say beam solar radiation, or you can say that direct solar radiation. Then we are having this, this is called as a shaded pinometer. It is used to measure say diffuse component of solar radiation. So in your so institute you can install this pinometers for measuring the say global solar radiation, and that solar radiation data you can utilize for the say BTech project or for say research work. Now, now, why we require solar radiation prediction? For our Indian sites, one of the most important reason is that for most of the site, we are not having measuring instrument. Only few sites are having measuring instrument. Therefore, we have to develop AI model, or we have to develop any type of predictive models using the data, major data of that particular site, and we can predict the solar radiation data where we are not having the measuring instrument, and we can use that solar radiation data for seeing the performance of photovoltaic system throughout year, and then we can integrate that system or photovoltaic system to the grid for say steady part. Now here as the world pivot towards say clean and sustainable energy sources, so among all clean and sustainable energy sources, the solar energy is a most promising one. So its efficient utilization is a accurate prediction of solar radiation, which determine the feasibility, design, and performance of solar power system. Now, importance of solar radiation forecasting in say renewable energy. So it play a very crucial role. First one say optimizing the output of solar plant. Once you know the accurate say solar radiation value, then you can optimize the output of the solar photovoltaic system. It is useful in say balancing energy supply and demand within a smart grid. It reduces operational cost by energy storage management. It supports grid stability in system with high penetration of solar power. And this accurate forecast, it enhances decision making for energy providers, policymakers, consumer, leading to more efficient integration of solar power into national energy mixes. So that's why, with the help of this point, that it is very important for say consumer side or policymaker sides, the forecasting of the solar radiation is very much important. Now, in forecasting, there is a different types of challenges. Okay, so challenges in say solar traditional solar radiation prediction. So first, we will see some conventional method which we are using for say solar radiation estimation. What we are doing in say conventional method with the help of say sunshine values, we have to develop say conventional equation. Conventional equation or say mathematical equation which is based on say angstrom type of model. Then we can use those mathematical model for estimating the solar radiation value. So conventional method in literature are empirical formulas, satellite images, ground-based meteorological observation. But nowadays this conventional method have several limitations because it is limited in accuracy, because due to cloud cover or aerosol presence, and inability to generalize across diverse geographical terrain. As we have seen in our say India, it is divided into 6 climatic zone. Therefore, on 6 climatic zone, we are having different types of different value of solar radiation. So, in southern part of India, solar radiation value is different. But when we consider say north part of India, there we are having different types of solar radiation value. So that's why when we develop this solar radiation by estimation model for any part of, say, southern part of India, if we use that estimation model for, say, northern zone of India, so there we experience substantial error. So therefore, we can say here that we cannot generalize this empirical formulas of solar radiation through all part of India, and it depends on, say, high quality data which may not available everywhere, because we are not having installed solar radiation measuring instrument for different sites. These challenges make it difficult to provide high resolution, short term and long term forecast needed for efficient solar energy planning. So, therefore, we require, say, advanced computational model to overcome the shortcoming of this traditional method. So advanced computational method, nowadays we are having, say, deep learning models, machine learning models, and in hybrid model we combining more than two model, taking advantage of both this model to make our prediction accurate. Then we are having this time series forecasting techniques. It is powered by, say, artificial intelligence. Now, at this point of time, we have seen that what are, say, different components of solar radiation, how we can estimate solar radiation, what are, say, different limitation in estimating solar radiation. So therefore we require advanced computational model. Now here we will see some deep learning for solar radiation prediction. Now try to see what do we mean by, say, deep learning. So it is a subset of machine learning, and it utilizes, say, neural networks with many layers. That's why it is called as deep, to model and learn complex pattern in large amount of data. It is inspired by human brain. What are, say, advantage of this deep learning? It learns it learn to extract feature automatically from raw data without the need for manual feature engineering. So what are, say, different key characteristics of deep learning? It uses multi-layer neural networks, and it has learning of, say, hierarchical features, and it requires large data set. Therefore, it requires high computational power. When we say high computational power, it requires, say, more storage of GPU and CPU. So it can estimate, say, image, natural language processing, time series forecasting, and more. So nowadays we are using these different types of, say, deep learning models. So basically try to see the difference between, say, deep learning architecture and, say, ANN architecture. Try to see this figure. This is called, say, artificial neural network. Here we are having this input layers, and this red circle is nothing but it is a neurons, and this is called as a hidden layer. And in hidden layers we are having this orange circle, it is called as a neurons. And here we are having output layers. In output layer, this is also called as neurons. So between input layers and hidden layer, we are having different uh, uh, different connecting bits which vary from say 0 to 1. And here at this point, there is say all output which are coming from this input layer, it get here sum up, and it will pass through the given activation function what we are having in these neurons, and the output will again pass through this point to the output layer, and again at this point all incoming input gets sum up, and again it will pass through the activation function, and here you will get the output. When we see here deep neural networks, this is your say input layers, and here your so output layers. Between input layers and output layers, number of layer get increases. Means you can say that when you are having more than one hidden layers in a network, that is called as deep neural network. When we observe the deep neural network, complexity get increases, but it is useful for say complex tasks. Now try to see the difference between say deep learning and say traditional machine learning. See here, in terms of features engineering, in traditional machine learning we are using manuals. In deep learning it is automatic, learn from data. Performance with big data, in traditional it is limited, and in deep learning it improve with more data. Considering model complexity parameters, in traditional machine learning we can use say decision tree support vector machine, but in deep learning we are having deep neural network with many layers. Computational power requirement is moderate in say traditional, but it is more in say deep learning, because here we require high value of say GPU TPU. Interpretability, it is easier to interpret traditional machine learning, but deep learning it is often seen as black box. In application domain, structure oblique tabular data, but here we are having unstructured data, image and speech. Now, a popular deep learning architecture for time series prediction. So basically, this is the say basic architecture of say ANN models. Here input layers, from input layer we used to provide the input. Then here we are having hidden layers. In hidden layers, computational part take place, and then at output layer we used to get output. So what inputs which is coming at say input layer, it is multiply with the connecting bit with the associated connecting bit. Say here x1 xi up to xn, these are say input. Here we are having bit wi1 wi is the bit, and here we are having summation, and all these get here sum up. Then again after summation it will pass through the activation function. Then in activation function, here we are having say alpha. Here we are using this activation function. Here it is a sum of say xi wij, and means multiplication of input bit connecting bit. Again it get sum here, right? Again it will pass through the activation function f. And this activation function, we are having different types of activation functions, say sigmoid activation function, hyperbolic activation function. Then we are having say ReLU activation function, and based on say activation function, the output get varied. The output of the say hidden neurons get varied. So again it get multiplied by its different connecting bit. Again in the same way here we are having activation function, again we will get the output. So this is the basic ANN architecture, where we can see that how we can get output once there is input at say input layers. Now, how information process in say neural network input. So input here say input layers. After input layers, you are having weight. Then weight here you are having say summing unit. Then after summing unit here we are having activation function unit. Then activation function unit here we are having learning process. Again learning process, then here you are having updation of bit. So this is the model for processing element. Now how we can train these AI models, artificial neural network model. So here we will see supervised training, when both inputs and outputs are provided. So the network process the input and compare its result output against the say desired output. So, based on this comparison between output and say target, we will get here say error, which is called as say mean square error. So, here n is the say number of say data samples. So, the error which is produced here, it is propagated back through the system, results in adjusting the bit in order to control the networks. So during training process, the data is processed several times as the connection bits are refined. Suppose we are having say 100 sample of data, we are using say 80% of data for training the model. What is happening in training the model? The error is generated based on say output and target variable, um, and that error is propagated back, and based on that error again the connecting bit get updated to minimize the error. Once the error is minimized, then we can say that our AI model is trained. What is a different simple supervised training flow chart? Suppose here there is say some training patterns. After this we have to update the weight and bias based on comparison with target. Then there is epochs is one complete sweep of training, testing and say validation. Then here we are having stopping condition. If it is yes, then we have to stop. If it is no, then we have to repeat training process again and again. Then what are say standard ANN solar radiation prediction pipeline? So through input, first of all, we have to divide the data. Suppose we are having 100 set of data, then we have to take 80% of data for training and remaining 20% of data for testing. So through this data set, first we have to separate the data. Then we have to use a feed forward or feed backward model. Feed forward means information process from say input to output layer. Feed backward means information process from say output layer to input layer based on computed error at say output layer. So after this we have to select training parameter. Select training parameter, then we have to train the model. Once we train the model, then we have to see the error, how much error is having in that model, because error is everywhere. No model is free from the error. So how we can calculate the error in model, like say mean absolute percentage error, R value, regression value, R square value, root mean square error, mean bias error. Then we have to say deploy that model, or we have to select the model for say our prediction one. So this is the standard, you can say that, solar radiation prediction flowchart. Now, at this point, we have seen, say, basic component of, say, artificial neural network. What do we mean by training and testing data? So now we will see some, say, deep learning model as per our, say, advancement, what is going on in, say, current scenario. So first we will take here convolutional neural networks. It is a type of deep learning models, and we are using this for image processing. This learn spatial hierarchies of features automatically. So major application are object detection, image classification, and segmentation. So try to see the architecture of this CNN model. So at CNN model, basically we are using for say image classification part. So on through even at input layers, so image are divided into pixel. This is one pixel, and it get passed through this convolutional layer, and at this convolution layer feature extraction take place. Feature extraction here take place. Okay, so now we can see here on convolution layer we are having say different features of the image, then it passed through the pooling layer. This on At pooling layers, important feature extraction of image take place. After this, it is passed through say fully connected network for say classification part. Classification part. Now, what are say different key components of convolutional neural networks? Say first one say convolutional layer. It extract spatial features, and say pooling layer, it reduces dimensionality. Then we are having say fully connected layers, uh, and at here at fully connected layer classification is performed. Then we are having activation function. It introduces say non-linearity in the networks. Then after this, how we have to compute say accuracy of the model with the help of say loss function and optimization. So this is the say architecture of say solar radiation prediction. Here we are having say input layers, then we are having convolutional layers, then we are having say fully connected layer, this one, then again here we are having output layers. So this convolution neural network, it is used for say image classification. Now, then come into existence that another network called as a recurrent neural network. Nowadays, we are experiencing sequential data. Now, question arises how we can process this sequential data. So, basically, this can be done by recurrent neural network. It is used for sequential data processing. Now, here it has memory, but what we have seen in say previous neural network are say not having memory, and it is independent of each other. And this recurrent neural network it considered past and say current input while it is making prediction. Now, why we require recurrent neural network? Because traditional neural network like say feed forward neural network cannot handle sequential data like say time series, speech or say natural language. In that case, this recurrent neural network are effective in say speech recognition, forecasting, text generation, machine translation, and say uh, uh, as well as say time series prediction of say solar radiation data. Now, what are say different application of this recurrent neural network? Speech to text. Next one say machine translation. Suppose you have to translate say from one language to another language. There, in that case, it is very helpful. Stock market prediction. Now here, once you know this recurrent neural network very well, then you can predict stock, and there you can uh, earn money. Next here, text generation. Suppose you have to summarize any text or you have to write any and say component of your examination, then there you can use weather forecasting. Okay, so in most of the case, you can see you can use this model for say to forecast the upcoming weather. Now, this architecture, this RNN, it consists of say input layers. Input layers here take input data, example sequence of word or number. Then we are having hidden layer. It process the current input and maintain a memory of past input. This is very much important here. Here it has a memory. Okay, so that's why it retain past information, but it is not possible in say traditional neural network. And at output layers it produces final result. Example say next word in the sentence, predicted stock prices. Now try to see the here comparative analysis between recurrent neural network and say feed forward neural network. Try to see here. This is the pictorial diagram of say feed forward neural network. But when we consider a recurrent neural network, here you are having one feedback path which is used for say retaining of say past information. Now, how it works? Okay, so this hidden state, it act as memory, passing information from previous time step to the next step. So this modeling equation is used in say hidden state of say recurrent neural network, where this f is say activation function. This f here is say tan hyperbolic bolic function or ReLU function, and this W is stand for say bait matrices, and ext here you will find out input. B is the bias. Okay, so why we require bias in any networks? Because this bias is helpful in the network to achieve the threshold limit. Otherwise, if the network is not able to achieve the threshold level, then one cannot get the output. So that's why in network we are using this bias value. It is called as B. Now, unrolling and say recurrent neural network, it is unrolled say over multiple time when it is used to process a sequence of data. This allows the network to capture dependency between past and present input. So in say solar radiation forecasting, this network is forecasting is dependent on say past input. Okay, what is the value of solar radiation on say previous day? Therefore, we can use this recurrent neural network in say forecasting of solar radiation value, and that value we can use in our say research work. Then how we can train and say recurrent neural network? Step 1, forward propagation. Input data passes through the networks. At each time step, hidden state updates based on current input and say previous hidden state. So output is computed at say final time step. Then there is a in step 2 loss calculation. So it is the difference between say actual value and say prediction value. It is given by say mean square error for regression task. This is very important. So through network we are doing say tasks such as say regression tasks as well as say classification tasks. In both part means our error matrix get different. So in regression tasks we are using this mean square error, and for classification tasks we are using here say cross entropy loss. Then here back propagation through time, similar to back propagation algorithm in feed forward neural network, but applied over multiple time steps. Gradient are computed for each time step and get sum out. Now here in back propagation algorithm means gradient are computed. That is a partial derivative of error with respect to bit that is computed. Now, what are say different challenges in training say recurrent neural network? First problem here say vanishing gradient problem, because here it is based on say back propagation algorithm, and this back propagation algorithm utilize computational of gradient. Next, so therefore, in recurrent neural network, we are using for say longer sequence of the data, and in that case, the gradient get vanished. What do you mean by gradients? A partial derivative of error with respect to bit. Suppose your error in say x square. If you take say first derivative, it will become 2x. Again you will take second derivative, it will become 2. Again you will take third derivative, it will become 0. Okay, so that's why it is called as a vanishing gradient problem, right? When the gradient get vanished, then our base cannot get updated. So before this in previous slide we have seen the connecting bit, which is between say input layers and say hidden layer, and hidden layers again to output layer. That bit updation should be maintained while training the network, but as gradient get vanished, the bit updation cannot take place. So therefore this is one of the important challenges. Second one say exploding gradient problem. When gradient become too large, suppose if you are having partial derivative value say very large value, then in that case training become unstable. Third challenges here say long-term dependency. Standard recurrent neural network struggle to learn relationship between distant time step, because here this recurrent neural network, suppose we are having say longer sequence of data, right? In that case this model is not able to understand the relationship between say first data to 100 data, or you can say that 100 data to 200 data. That is called as a long term dependency. So these are say important challenges in say recurrent neural networks. Now how we can solve these challenges? Once these challenges is solved, and this give rise to a new network that is called as long short term memory, are called as LSTM network. Here long short term memory, it it introduce forget input output to retain important information. Then we are having gated recurrent unit, a simplified version of LSTM but faster and effective. So when we see here LSTM, it is the type of say recurrent neural network, and it is designed to overcome limitation of say traditional recurrent neural network, like say Bayesian gradient problem, right? So LSTM, it is useful for tasks where long-term dependency are important, and we can use this LSTM for natural language processing and other sequential data. So what are say key features of LSTM? It includes memory cells, gated gated memory mechanism, means it include three gates: forget gate, input gate, and output gate. Forget gate, it decide which information to discard from the memory cell, because memory cell has a limited space. That's why this forget gate is important. Input gate control which new information to store in the memory cell, and then we are having output gate regulate what part of memory is used to compute the output at each stage, right? Now this is the say architecture of say LSTM figure. Here you are having forget gate, input gate, then we are having this output gate, here we are having memory. So you can understand this LSTM network in the same way. Suppose you are reading the book and your mind retrieves say important information, and that information again get updated with new information, and your mind discard less important information. On the same concept this LSTM model is working. So here we are having this forget gate. It is used to forget less important information, and input gates, it is used to control the information through these networks. Then this is the say again LSTM architecture for solar radiation prediction. Next, what are say architecture of LSTM? It has cell state, the memory of LSTM unit, hidden state, uh, the output of LSTM unit at each time step, which can be passed to the next input. Forget gate control what portion of previous memory to retain. It is computed with the help of this modeling equation. Input gate, it determine how much of the new input should be added to the memory. So here this is the modeling equation which is used in say input gate. Then we are having candidate memory. So here we are having this temporary memory update is based on the this input. Output gate control how much of the memory affect the next hidden state. Then we are having finally memory update. The cell state is updated using both input and say forget gate. So based on this modeling equation, this LSTM network is working. Now why use LSTM? First we have seen here overcome of vanishing gradient. Second one say capturing long term dependency. It is useful for tasks where the context over long sequence matter as speech recognition, machine translation, and text generation. It is flexible. It can effectively learn when to retain or forget information over time. It is highly adaptable to various type of sequential data. Now after this LSTM, this attention mechanism came into picture. Now try to see what do we mean by attention mechanism. Suppose you are reading a book. You don't you don't read every single word with equal focus. Your brain attend to most important part to understand the story, right? Suppose it happens to everyone when we are reading a story, and in that case your brain pay attention on say important part of the story to understand the whole part of the story, right? Similarly, in deep learning, there is a attention mechanism, right? It allow model to focus on relevant part of input data. So what input data which we are giving to the model, it focus on say the most relevant part of input data instead of treating all information equally. So it is useful in tasks like language translation, text summarization, image captioning. Before attention, model had difficulty in handling long sequence of data. Now when attention mechanism uh, came into picture, this problem is solved by helping model decide what to focus on at each step. Now, what is attention mechanism? Here, it is a method that gives different weights importance to different part of input when making a decision or prediction. You can understand in another way. Think of a student preparing for exam. They will give more time to difficult topic and less time to easy one. Similarly, attention tells the model where to concentrate its effort. What are say key features? Say here we are having selective focus help model prioritize. Dynamics, the focus can change based on based on the task, and it helps it say longer sequence like say paragraph or say time series. Now how attention mechanism work, this is very important. Let us take an example from natural language processing. Suppose we have to translate a sentence. The cat sat on the mat. So, and it's generating the French word for cat. The model here look at entire sentence and give higher attention to the word cat and lower attention to irrelevant one like mat or on. Once we get here this part, so here we are having query what we are looking for. Then we are having say key label for input, value actual information of input. So with the help of this modeling equation, the model calculate attention. This formula give weight to different parts of input. The output is weighted sum. More weight means more important. Now here, how attention was introduced in say deep learning. Now, initially, we are using this recurrent neural network and LSTM for handling a sequence of data. But there is same problem in this model also, like say poor performance on long sequence of data, forgetting earlier word, right? Then attention mechanism, it was introduced in say 2014 by uh, by Bahadino ETL for neural machine translation. It helped the model look at all words in the input sequence while generating each word output word. Then in 2017, Google introduced the transformer model in the paper Attention is All You Need, which used only the attention, no recurrent neural network or CNN model. Okay, so now here at this time, the application of the attention model you will find in say your say chat gpt which you are using nowadays. Now this scientist Bahadeno play a very important role by developing this attention model. Then in 2017, this Google scientist developed transformer model, and they utilize this attention model. Okay, because they have not used say no recurrent neural network or say convolutional neural networks in their models. Now, what are transformers in artificial intelligence? So don't be confused about say transformer in electrical engineering that is used for say step up and step down of voltage, right? Here it is different. Here it is a transformers in artificial intelligence, right? It is a types of model which was introduced by Google in 2017 in paper car Attention is All You Need. It is used to handle sequential data like say text text, audio, or time series data. And these models are not used in recurrent neural network or say CNN. So here transformer is rely on mechanism called self-attention, which allow the model to focus on different part of inputs simultaneously. So this is the main important part of say transformer model. It used to focus on different part of input at the same time. Instead of processing input step by step like recurrent neural network, transformer look at entire input at once using self-attention mechanism. So this is the important part. In recurrent neural network, information process step by step or time by time. But due to invention of say transformer model or say self-attention mechanism, this model look entire input at once using self-attention mechanism. Why are transformer important? As it revolutionized AI, especially in the field of say natural language processing. It can handle long sequence more efficiently than recurrent neural network or LSTM. It enables parallel processing. It requires faster training or GPU, provide state of art result on many tasks. So they are the backbone of most powerful model like ChatGPT, or you can say that BERT, which is used in say Google search. So these are certain say reference from which we we took. So from nowadays, if you want to study, you can consider these articles which we have published just in say 2025. Before this, if you want to see, you can see this article say which was published in say 2015 by our research teams. Then apart from this, here again you can see one article that is a rapid miners in NN based prediction of solar radiation. Here we have used this rapid miner for selection of say relevant input variables. So you can use this in your say mm, study. Now we will see some say hands-on practice or implementation of this with the help of say certain say Python coding. Okay, so uh, what we want to see with the help of this coding, first of all, suppose we want to predict solar radiation based on different types of input variables. So this is say Google Colab library. So once you write here in say Google here if you write here say Google Colab Google Colab, it will get automatically open. So here once it is opening, so you can take a new notebook, okay, new notebook. So once new notebook is loading here, so it will come. So you can write it here code, and this button is for say running the code. So this is very easily available. So this is based basically on say Python. Okay, so to run this solar radiation predictive type of models, we require say different types of libraries. Okay, so first here we should import pandas at pt, import numpy as npy. So this is used for say data manipulation part. Then we have for sklearn model selection, import train test split. Then here we are having import mlp regressor. Then here we are using this import min max scalar. Min max scalar means it is used to bring the data value between say 0 to 1 for efficient training. Then with the help of this scale learn that matrix import mean square error, mean absolute error, r square value. So this we are importing to find out the error between say predicted value and say measured value, because this model is used to provide say accuracy of the model, right? Then here we have to use a matplotlib pyplot at say plt. It is used for say plotting, right? So from Google Colab you can import the file. Okay, so here you will find out one part for importing the file. Okay, you can import it here also. Okay, so after this try to see here what command we have to write for to upload the excel file, right? Because in excel file we are storing the data, and we have to import the data for say prediction part. Here in step third, upload the Excel file. Here we are having uploaded files dot upload. Then here files name list upload dot key. Then here df is equal to pd dot read Excel. Here we have to give the file name. Then after this, there is a pre-processing task. df.drop. So suppose in your say Excel file, if any data is missing, okay, or if you are having say NaN value, right? Because we are using say measuring type of instrument, and due to sensitive issue, sometime data get missing in the Excel file. So therefore, we are using this code to remove the say missing value in the data. Suppose here we took say 17 input features and one target. Target here we are having say solar radiation variable. Then here input columns defined say here 17. Then target here def column 17. Right? So once we import these two parts, okay, input variable and target variables, then we have to separate it into say input features and say target feature. X is equal to say def input columns dot values. Here y is equal to def target columns dot value dot reshapes minus 1 say 1. Then what we have to do? Normalize inputs and target. So with the help of say scalar x, min max scalar, we have to normalize the input and target. Then x scalar x dot fit transform x. Then here scalar y, min max scalar y scaled scalar fit transform. So this is x scale value, this is y scale value. Again we have to make the this value between say 0 to 1 for efficient training. So at this point of time we have done say data processing tasks. Next we have to do say train oblique test split. X train, X test, Y train, Y test. So with the help of train test split, we have to X scale, Y scale test size, right? After this, we have to build NN models. NN models using say MLP regressor. So here we are using say Levenberg-Marquardt algorithm. Okay, for say efficient back propagation algorithm, right? So here we are using this model MLP regression. Hidden layer size we took here 32 and here we took here say 16. Activation function we took here say ReLU. Then after this we have to go for say prediction. Y prediction scale model that predict X test again reshape into say -1 to say 1. Then again because before this we have done say normalization of the data, then we have to bring that data into original scale. So that's why we are using this code. Then after this, we have to evaluate the model. How we are evaluating the model? Mean squared value, mean square error. You should write here mean squared error, y test here, y test I and B, y predict this one. Again mean absolute error here, y test I and B and y predict this one. Then again root mean square error NP dot sqrt MSC. R square R square. Now you see here, uh, say this is the difference between say MATLAB and say Python Google Colab. So in MATLAB we used to write the equation, right? But here we have to directly call the library, and that library used to solve the problem. So here after this, after evaluating the model, then we have to print all these value: mean square error, mean absolute error, root mean square error, R square value. So once we print this value, then suppose we want to see the plot value, plot actual versus predicted value. So here figure size say 10 and 6. Okay, so you can change this dimension also. Then we are having say plot y test label. Here we are having measured solar radiation. Okay, suppose if you want to add color, you can add here say color. Again line width, you can change the line width. Here Y predict label, predicted solar radiation, color rate, line style, then PLT dot title, comparison between measured and say predicted solar radiation. Here plot X label sample index, plot Y label solar radiation. Okay, so here if you want to give the error legend, okay, so here suppose you want to see it in the grid, okay, then you should write here plot grid. Then after doing all this part, you have to run this part. So once you run this cell, you will get here say data value here. Again, then you choose this file. Once you choose this file, then you will get here say mean square value say 2.60, mean absolute error say 1.275, root mean square 1.65. Here r square value, here we are getting say 0.751. So here you are having say comparison between measured and predicted solar value. So you can see in say in this image, try to see here this solar radiation. Here measured solar radiation, it is shown by this blue color, and this predicted solar radiation, it is shown by this dotted color. Okay, so in this way you can use this part in your say research work for say publishing a paper.